Today we're going to look at geometric sequences and series. And so we talked a little bit last week about a geometric sequence being that list of numbers. All series is series means the sum. So, for example, last week we looked at geometric sequences. And those were ones like we had 3, 6, 12, 24, and it kept on going. We might have had, let's see, 2, 8, 32, and it kept on going. And all of these we said we had a ratio. And again, to get a ratio, if we're not sure, we take a term divided by the previous term. So our ratio is 2. We take a term, and it doesn't matter which one, divided by the previous term, our ratio is 4. And then if you remember from last week, to write the geometric rule, it was a sub 1 times our ratio to the n minus 1 power. So this first one would be to find any term. It's our first term times 2 to the n minus 1 power. This next one would be our first term times 4 to the n minus 1. So what we're going to look at today, though, is how do we find the series, or how do we find the sum of these? So there's 2 formulas that we are going to be using today. And so the first one is the sum of a certain number of terms is our first term minus a sub 1 times r to the number of terms divided by 1 minus r. So again, right here, this is our first term. We have our ratio, and we have the number of terms. And the hardest thing on this is really typing it into the calculator, and we'll talk about how you use Desmos to do that. So the first problem we're going to say is find the sum of the first 6 terms. And we have 100, 123, 151.29. So first thing, this one isn't obvious. We don't know what our ratio is. How do we get from one to the next? So our ratio is 123 divided by 100. So let's see, if we go to Desmos here, 123 divided by 100, 1.23, and let's check and see if that works. 151.29 divided by 123, yep. So we got 1.23. So if we need 6 terms, we have the first 3. So we could say 151.29 times 1.23. Whoops, that didn't work. So we have 186.0867. Then we could keep saying, well, times 1.23. We have the next one, but you notice these decimals get really, really long. So it might be easier to use our formula. So our formula, and again, you'll be able to reference this, the sum of the first n terms, our first term not going well, guys. Minus our first term times our ratio to the n power over 1 minus r. So if we fill in those blanks, we have our first term of 100 minus 100 times 1.23 to the 6th, 1 minus 1.23. So to type it into Desmos, just make sure you're using parentheses there. So parentheses for the numerator, 100 minus 100 times 1.23 to the power of 6. And again, just watch your parentheses, because if we do a divide by, it turns into the fraction 1 minus 1.23. And we have 1070.79. Would be the sum of the first 6 terms. So again, it's just filling in those blanks there. So the second one we're going to look at, if we had to find the sum, and we had 4, 12, 36, all the way to 6, 3, 7, 7, 2, 9, 2. So again, we don't know how many terms there are, and we don't know what's in the middle, but I can look at this and say, okay, I know it's times 3. So we can use that formula, our first term minus our first term times our ratio to the n power, 1 minus our ratio. And we can fill in a lot of these blanks. Our first term minus our first term times our ratio. Oops, what happened there? Sorry, guys. So we don't know what power 1 minus 3. So what we're missing is those number of terms. So what we can do to find that is we can use that rule that we said above. To find any term, it's our first term times our ratio to the n minus 1. So we know we want to find the term number for this. Our first term is 4 times 3 to the n minus 1. So we can use some Desmos to do some dessing and checking. 4 times 3 to the power, we have to put parentheses, so 10 minus 1. Nope, not big enough. 11 minus 1. Nope, let's jump 13 minus 1. 15 minus 1. Oops. Let's see, is that too big? Yeah, that's 19, so 14 minus 1. And there we have it. So we know that this number right here has to be 14. So that means our number of terms we're summing is 14. What is going on? I apologize, you guys. So let's go back to Desmos. So we have 4 minus 4 times 3 to the power of 14 divided by 1 minus 3. So we have 9,565,936. So our sum right here, 565,936. So let's take a look at a word problem here. Let's say Miss Husing's YouTube, these lovely videos, got 610 views the first day. I mean, I'm going to start getting paid by YouTube here. And it increases by 30% each day. And we want to know how many the total views on day 14. So if I was to make a list here, 610 views the first day. So how do we get to the next day? A 30% increase. That would be times 1.3. So 610 times 1.3, 793. And times 1.3 for the next number. But we have everything we need. So we want the sum of the first 14 days. So again, using that formula, our first term minus our first term times our ratio to the n power divided by 1 minus our ratio. So we can go back here and so we got parentheses 610 minus 610 times 1.3 to the power of 14 divided by 1 minus 1.3. And look at that. I'd have 78,026 views. Now the last thing I want to talk about is what if I said the sum to infinity? So we're not defining a certain number if the sequence goes on forever. So let's say we have 2, 4, 8, 16, and we have 16, 8, 4, 2. So these are both geometric with different ratios here. Our ratio here is 2. Our ratio here is we're doing half. So I'm going to call this sequence A and sequence B. So sequence A, if I said what happens is the sum goes to infinity, well, the numbers keep getting bigger and bigger because we'd have 2, 4, 8, 16, 32, 64. So we would say it's an infinite sum because we keep adding a bigger and bigger number. But when we look at letter B, if I said the sum to infinity, the numbers we're adding keep getting smaller and smaller. 16, 8, 4, 2, 1, half, fourth, and eighth. They're getting to be tiny and tiny numbers. So if, and this only works for the sum if you go to infinity, if the ratio is less than 1, and it could be negative, but the absolute value has to be -1, less than 1, it's the first term over 1 minus r. So our sum here would be 16 over 1 minus half, which is 16 over half, which is 32. So eventually, if we keep adding these numbers, and we can kind of see this on Desmos here, if I do 16 plus 8 plus 4 plus 2 plus 1 plus 0.5 plus 0.25 plus 0.125 plus, what would that be, 0.12, oops, what happened there? Wrong app. 0.125 divided by 2 plus 0.125 divided by 2 divided by 2. Whoops, that didn't work. But we can see that it's getting really close to 32 because we keep adding smaller and smaller numbers. All right, so we're going to have you guys try the Delta Math assignment.